Hello everyone, May the 30th. Still struggling with what I need to do. No end in sight, no hope. But whenever I get down or really want to, I'm really not really looking for encouragement or anything. It's just, I like to go back to scenes in the past, movies I watched in the past, clips, and just get emotional. Well, anyway, not too emotional, I guess. Alright, so this we got it yesterday after looking through the hints. That one is a pretty tough one. But we closed the page on that one, so that's that. Alright, let's deal with this. The best movie that I've watched definitely is The Lord of the Rings. It was just so good. Every single part. Even the behind the scenes. Everything, And also hit like at the right age, I think, when it came out. Really young, really like this fantasy stuff. I don't know, I think it's important when you see things that come out at the right time and get a hit. But it's different. Back then, what intrigued me is very different from what's now. As you grow older, you start to understand things differently. Back then, the effects, right, all the fights, those are the main drive, and I fast forward a lot of the dialogues and a lot of the adults talking scene. But as you age, you start to gravitate towards those moments that you didn't really pay attention to in the past, but you did now, because you have experienced things, you have seen things, and in those moments, those so-called boring scenes start to make more sense and start to hit you differently. 20 years. Man, time does fly. Alright, design underground system. Alright, an underground railway system is keeping track of customer travel times between different stations. They are using this data to calculate the average time it takes to travel from one station to another. Implement underground system class. Check in a customer with an ID card. With ID, checks in at the station name at time t. A customer can only be checked into one place at a time. Check out. Alright? Get average time returns the average time it takes to travel from station to station. The average time is computed from the previous traveling times from station to station that happened directly, meaning a check-in at a start station followed by a checkout at the end station. The time it takes to travel may be different from the time it takes to travel from end station to start. So it has to be, do two. There will be at least one customer that has traveled from this to this before get average time is called. You may assume all calls to the check-in and check-out are consistent. If a customer checks in at times 1 and checks out at times 2, then T1 smallest than T2, all events happen in chronological order. So it's okay. So basically we're just going to have a big dictionary. Okay, so the big dictionary, what we need, this is a designing problem, because we need station to station, which means if I query station to station, I need a dictionary with station, okay, and inside should be another dictionary where we have end station, and then we need to have time. Right, that's how we do. I mean, it'll be even better if we have the total and the number of traversal, and then we can just do the division. So this one can get in 01 time. So when you check in, right, you have the station name. Okay, can go to the station name. And then you have the person. Person is here. So we need another dictionary, right? We need another dictionary with person ID. So when the person checks out, so you know the end, and this person has the station name and has a starting time. And when the same person checks out, then we have the station name and another. So we have the station pair. So yes, so I will use 2 dictionaries for this. 2 dictionaries. Okay, 2 dictionary shall do. 1 dictionary to record the person. Okay, so I need 1 self.customers. Okay, that's gonna be a dictionary. And the other is stations. All right, and then when we check in, we say self.customers ID. Ooh, this person might check in multiple. Well, I don't think so. It's that each person can only check in once. So I don't have to worry about it. I can just, when they check in, we can say station name and time. Okay, when we check out, so we go to the, we can say start and the start name. Okay, start name and start time equals self.customer.pop ID. Okay, and then self.stations, your station name, no, your start name. And say, hold on, if start name not in stations, self.stations start name, it needs to be a dictionary as well. And then we say self.stations start name and station name, this is the end. The time travel, I think, is just minus. Yeah, just minus. So the start and this shall equal to, let's do this one more time. If station name is not in self.stations start name, then we need to say this shall equal to 0 and 0. So total time, number of trips. Okay, so now we set them up. Then we can say self.stations start time, start name, and station name 0 plus equal to t minus start t, and self.stations start time station name 1 plus equal 1, and get average, which is return self.stations start station and station total num trips equal to this, and we return total divided by num trips. This shall do. Just give it a shot. Start station is not defined. Of course it's not, because it's not start station. It's, oh, do you want to remove this? Actually, it doesn't really matter, because I already just assigned it another one, so it's okay. Customer is okay. Yep. This shall do. Yep, this did. May badge. Okay, I just want to see if I use the same method last time. Okay, that's fine. Check in, check out, check the gate. Yep. I mean, I use a default dict. It's slightly different. Oh, start and this is actually smarter. This is actually smarter. The pair. You get the pair this way. Yeah, I like this one better, but it's okay. It's okay. All right, so we're done with this. Let's keep moving on. How many do you want to do today? Maybe 2? Form smallest number from 2-digit arrays. Given 2 arrays of unique digits, nums 1, nums 2, return the smallest number that contains at least 1 digit from each array. Wait, hold on. Given 2, return the smallest number that contains at least 1 digit. 1 digit from the array, from each array. So the first one, 4, 1, 3, and 5, 7. The number 15 contains digit 1 and a 5. This can be proven that 15 is the smallest number. Number 3 contains digit 3, exists in both arrays. So basically, we want to find if there is any overlap between the two. If there's any overlap, we should find the smallest. If there's no overlap, then we find the smallest on the first and the smallest on the second. Okay, so that's that. How do you find overlap? Intersection. Overlap equals set nums1 dot intersection nums2. If overlap, turn minimum overlap. Otherwise, return minimum nums1 times 10 plus minimum nums2. I think that shall work. Give it a shot. Oh, it doesn't have to be nums1 at first and nums2 at second. Grr. AB equals minimum nums1 and minimum nums2. So we shall return minimum of AB and maximum of AB. Ugh, that was pretty bad. Yeah, it didn't really say which one is to go first. They didn't say. Oh, got hit by it. Yep. Yeah, got hit by the fact that there's no requirement that the first digit must come from nums1. Thus, we have to find the smallest between the min of nums1 and min of num2 as the first digit. Any better solution? Intersection. Yeah. Okay, so this is done. Find the substring with maximum cost. You're given a string chars of distinct characters and an integer array vowels of the same length as chars. The cost of the substring is the sum of the values of each character in the substring. The cost of an empty string is considered 0. The value of the character is defined in the following way. If the character is not in the string chars, then its value is its corresponding position, one indexed in the alphabet. For example, A is, okay. Otherwise, assuming I is the index where the character occurs in the string, then its value is vowels I. Return the maximum cost among all substrings of the string S. So ADAA, so maximum substring is going to be AA, right? ABC, that's going to be 0 because empty string is a substring. Okay. What do you think? Well, let's try DP on this. Okay, we have ADAA, right? So we want to find the maximum cost of all the substrings. So we can say that we want to find the maximum substrings ending at here. So we start with 0. So maximum substring ending at this. Okay. So maximum substring ending at this. So we have the previous max. And we say for this is going to be either I include it or I don't include it. So the max, hold on. It should be the max substring ending at here. Ending at this. Well, ending at this means we have to take it. And then this will look into, so that will be 1. The maximum ending at this. So we have to take this, right? And we want to find a maximum here, which is minus 999, all right? The maximum ending at this. So I either take this or I take by myself, or I have to take this. So I best definitely take by myself. It's going to be 1. The max ending at here, the maximum here, so it will be 2. So the max will be 2. All right, in ABC, the max ending at this is minus 1. Max ending at this is minus 1, max ending at minus 1. So it's going to be minus 1, but the rest is going to be 0. So therefore it's a 0. Okay, so that shall be pretty straightforward. The beauty of substring is, we can always go, 1 back, right? So we can say rest is equal to 0. And then for, you don't need I, but 26, I can just do index, it's okay. So for letter in S, okay? For letter I, we need a pre, okay? The pre. The pre is going to be, okay, res and pre. Pre is going to be minus math.inf, okay? So for I, letter in enumerate, do you need I? I don't need I, just for letter in S, okay? So C is a cost. We say, what's what's index? Let's say in ABC, okay, dot index A. Okay, how about D? Oh, damn, I have to. Oh, I don't like it. Indices equals for I letter in enumerate chars. Letter I. Okay. All right. For letter in S, if letter is in indices, C equals indices letter and vowels. Else C equal to ord letter minus 96 because ord A is 97. That's correct. So let's do it this way. If else okay, so this is our C. Cost. Now we can say pre shall equal to what's the maximum of this? So it should be the maximum of pre plus C and C by itself, right? So I take it either by myself or I combine with previous. And rest shall equal to maximum rest and pre. And then we'll return rest at the end. Okay, I have confidence. Let's just try these and then if it works, then it works. Yep, it works. That's good. DP. Cardang. Oh, that's the word. Jesus. Oh, yeah, I'll convert to this and become a Cardane. That is true. Yeah, it's the maximum longest, no, it's the sum, substring sum, subarray sum, maximum subarray sum. Oh yeah, that's exactly the same. Make k subarray sums equal. You are given a zero-indexed integer array and an integer k. The array is circular. In other words, the first element of the array is the next element. The first element of the array is the next element of the last element, and the last element of the array is the previous element of the first element. The last element of the array is the previous. Okay, you can do the following operation any number of times. Pick any element from array and increase or decrease by 1. Return the minimal number of operations such that the sum of the subarray of length k, the sum of each subarray of length k is equal. Oh my word, this is fun. This is a very fun problem. I immediately like it. Holy crap. We have 1, 4, 1, 3, right? You want to pick any element, increase or decrease by 1, number of operation, each operation. So basically it's 1. So if we decrease this, if it is turned into 3, then it's k is 2. All right, so we're having this, right? 1, 4, 1, 3. K is 2, so I can compute. This is 5. This is 5. This is 4. And wraparound is 4. Okay? I mean, I can just add a 1. Yeah, so if it's 2, I add 1 because that's wraparound, right? 3 to 1, and then we start with 1. If we have k equals 3, then 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then so we add 2, right? So we can just put it up. So now we don't have to worry about circular anymore. Now it's just this, right? Now it's just this. So we need to change. Oh, but these values are the same. Well. But if you think about it, it's if you say we have A0, A1, A2, to AN, right? And then we have K. And then the next K. So A0 plus plus to AK minus 1. That's the first K. And then we have A1 plus plus AK. That's the next K. And the two are differ only by A0 and AK. Everything else is the same, right? So what we're saying is we have a bulk in the middle, K minus 1. And we have A0 here, okay? And then we have the bulk, and we have AK. So we want these two to be the same. So we need this to be equal to this, okay? Let's say they are equal. Okay, let's say they're equal. And then we're moving on, right? Now we have an A1 and then AK plus 1, right? So we want A1 to be equal to AK plus 1 and A2 to be equal to AK plus 2, right? Because the difference between this is K plus 1. So eventually we want A0 equal to AK, A1 equal to AK plus 1, A2 equal to AK plus 2, all the way until we're gonna mod AN, we can say AN is equal to AK plus N. Of course, all this have to mod, well, let's say minus 1, mod N, okay, mod N, mod N, mod N. Then in our case with 1, 4, 1, 3, okay, A0 is equal to 1, AK is the, what is K? The kth value. No, the K actually is the K, K plus 0, 1, 2. Oh, it is A2. AK is A2. So A2, right, is equal to 1. And then we want A1 equal to A3, right? And let's not do a, let's do another way. Okay, 1, 4, 1, 3. We want array 0 equal to array K mod N. And array 1 equal to array K plus 1 mod N. Right? So in our case, it's array 0 equal to array, and here N equal to 4. So we can say array 2. And this is 1 equal to 1. So we're good. We don't have to change. and we want array 1 to equal to array 3. So array 1 is 4 equal to 3. Boom, that's not right. So one of them need to change. So either change this or change this. So that's one operation, right? One op. And then we want array 2. Yeah, let's just change and say array the number of operations depends on the difference between this. So let's say we change this to 3. Okay, so let's say we change this to 3. Now we want array 2 to equal to array. Now there will be 4, need to mod 4, which is array 0. So array 0 and 2, that's good. And I want array 3 to equal to array 5 mod 4, which is array 1. Now array 3 and array 1 is good already because I changed it. So that's good. So I think I'll just do it like that and see if it works. I haven't checked the second one, which is actually good because I'll be able to use that as a test. So here's the idea. We need an array, okay, and the rest equal to 0. And we just say for i in range n, rest plus equal to array I minus array k plus I mod n abs, and then array I, we can do this, array k plus 1, let's compute it once, j equals k plus I mod n. So I can just do array j, okay, and then we say array j is equal to array I, and then we'll return res. Okay, give this a shot. 1 4 1 3 2 shall be 1, 2 5 5 7 3 shall be 5. Array k. The second one is not right. Okay, so we have to work on the second one. I don't know why, but it's okay. Let's just take a look. That is not right. That's not right. But 255, right? And 552. So I say I change this into a 2. I make 7 and 2 the same. And next one is 552. Two 5 5. Then for this 552, then I need to change this into a 5. Oh, it doesn't work. It does not work the way that I wanted. Why does it not work? 2557, right? So I have this and I have this. So they need to be the same. So 2 and 7 need to be the same. But they're not the same. But I should not just assign them to one value. Because in my case, I just assigned it to be 7. I just assigned this to be 2, so it becomes 2552. Now I need to do this. So now this needs to equal to this because it's 552 and 522. So these two need to be the same. Now I assign this to be 5. Next we want this and it's this and this. Now this and this, they're already the same. Finally, it's going to be this and this. Then I assign it to be 2. So final has 5522. But that's not right because, okay, 552. That's 522. So I need to keep going, right? Then we have 5 and we have a 2. Then we need to assign again, right? 5 and 2, because they're not the same. So I need to assign it. Become 5, 5, 2, 5. Then these two are equal. Then these two are not equal. So this will be assigned to be a 2. These two are not equal. Then this will be assigned to a 5. These two are equal. These two are not equal. Wait, are you saying just keep going on? Just keep looping through? Nah, that doesn't seem right, man. That doesn't seem right. But of course, that's what we want. We want this and this to be equal. So if they're not equal, we know we have to change them. Okay? Next, so we know these two are not equal, so we need to change these two. Next, we have these two compared, and they're not equal, so we have to change them as well. Next, these two are equal, and next, these two are not equal. So what we need to do, we need to change. We need to 0 and 3, right? We need to make 0 and array 1 and array 0 and 2 and array 3. So we need to make this equal to this and this equal to this and this equal to this. Now if this equal to this and this equal to this, so we can say, so these three, so 0, 1 and 3 must be the same, and then 0, 2, so 2 has to be in it as well. So now we know all of these has to be the same. All of them has to be the same. If all of them has to be the same, then we need to find the cheapest way of making them all the same. How do you find the cheapest way to make them all the same? Well, how do you know? How do you make... I mean, you don't know, but what you can do is to have the sum of this, right? The sum is 19, and then they have to be the same. So you can say for 1, so if it's 2, so 2 plus 4, 2 times 4 is 8. Or we can do 5 times 4 is 20. Oh, then I have different directions. Oh my god. Ooh. That's a good question. That's a good question. How many operations do you need? I mean, I can union find to know which one should be the same. That I think is doable. That is doable, right? That's not hard. We can union find, put the ones that needs to be the same together, and then we can say, okay, these values has to be the same. But now the question is, given these value, right? Basically, the question converts to, given the list of values that need to be the same, what value should they be? Well, I can sort them, right? Because I know they must be the same values. I can sort them. So from small, right? So from small to large, I can sort them. And the best will always be is there a way to do this? There gotta be a way to do it, man. See the average. So you can get the average. Okay, you get the average. And then actually really get the average. Or get the median. You get a median value. Get a median value. Really? Median value shall work? What is the value that can make it the smallest? I mean, it has to be one of the values, because then we can reduce. Can we just go through everything and then calculate how much we need? Okay, so we say 2. How much do we need? The number of operations. We do know, right? If we have 2, 5, 5, 7, right? We can say if we take 2, and let's say we also have their prefix sum. Okay, so say I want everybody to be 2. Then the total operation is going to be this, right? So it's 17 minus 2 times 3. That's 11. So we need 11 operations to make it. Right? 3, 3, 5. Yeah. If we do 5, then we can say, so that's going to be 5 times 1 minus 2 plus 5 times 2 minus whatever this is. This is 12, right? So that is going to be 3 plus 2, that'll be 5. And then we can do another 5. But if it's equal, then we can actually skip, right? If it's equal, we can skip, because it'll be exactly the same. And then we'll do 7. Actually, whenever we see the value goes up, we can stop, because that would get more and more. We have to do more and more. So we can just go from the smallest, and then if we see the value drop, we keep going until the value goes up. That might work, so I'm gonna try it this way. It's very, very different. So I need union find first. Oh Lord. Array length 10 to the 5th. Parent. If self.parent x is not equal to x, self.parent x equal to self.find self.parent x. Return self.parent x. Union px py find x. Okay, find x, find y. If px is not equal to py, if self.rank px is larger than self.rank py, self.parent py equal to px. If self.rank px is smaller than self.rank py, self.parent px equal to py. Else self.parent py equal to px, self.rank px plus equal 1, return true, otherwise return false. Okay, so we don't do this yet. We need DSU equal to DSU n, and we go through this, right? Then we just say DSU dot union ij. Okay, so once we're done, we need another function to find the find minimum operations to make all element equal of an array. Okay. So anyway, we do all this, right? Union, 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 union. I don't even need a J. Okay. So once we do that, what we'll need to do is to find who will be the same. So we will say groups, right? Groups. So groups shall equal to a default dict list okay. Then for I in range n, okay, everything I need to say groups DSU dot find I dot append I. So now I know all the groups. Then the answer shall be return for G in groups dot values. Okay. Self dot find this G and we'll sum everything. Okay, so now it's just to find the minimum operations of this, which is okay. So what I will do is I will sort it first. Okay, I'll sort the array and I'll get a pre-sum equal to 0 plus accumulate. Okay, list accumulate array. You know what? I don't feel like doing this. I will just as a pre-sum. Okay, so basically we say we choose every single one and decide which one is the smallest. So the rest is math.inf. Okay, so we say for I, A in enumerate array. So we say, okay, I choose the current I, right? And everybody to the left need to plus it to the right. So what do? We do this. The number of operations is going to be, okay, pre-sum I minus 1. Okay, pre-sum I minus 1. So the left, okay, left shall equal to 0. No, not 0. Left shall equal to 0 if I is equal to 0. Else pre-sum this and A times something minus pre-sum A times what? Times I, right? The total number on the left hand side. Right shall equal to the right shall equal to 0 if I is equal to len array minus 1. So like if I go to the last one, so there's no right, right? No right. Otherwise, we can say pre-sum minus 1 minus pre-sum I, right? Minus pre-sum I, which is the current value, because you don't include this. You want to everything on the right hand side, right? So everything on the right hand side, then minus A times the total numbers n minus total number on the right. So you're at I, right? So if you're at I, so there are total how many? There's I number. Wait, hold on. Right, you are I. There are I numbers on here, right? So I plus 1 number. So n minus I minus 1. Okay. Then we say if left plus right is smaller than rest, rest equals left plus right. Else we're gonna break. Whenever we get bigger, we can break. Then we return rest. Okay, try this. Rank. N is not defined. Damn it. Ew, that was ugly. The hell? Result of 4. Huh? I did not know what happened. That's okay. Let's see. Groups. Oh no. Let's see, what do we have for the groups? 0, 2, 1, 3, that's perfect. And 0, 2. Oh my god. My god. You shouldn't have pen I. Array I. There we go. There we go. Yeah. Alright, let's see the runtime. So this is ON. DSU, yeah, we don't consider it. This is ON, because this is O1. Okay, so this is gonna be number of groups. Oh, we always have something. At the most, let's say N groups. It won't be N groups. N divided by 2 groups, so N groups. So for each one, but we are essentially iterate through, because this is O1, 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 so this is ON, right? Array. And because all these are unique, so this is ON, so this is fine. This is fine. It just feels, you know, very complicated. I feel like this may be solved easier, but we'll see. Jeez, man. Which part is wrong? Expected 10. Okay. Let's see. Print groups. Okay. So we did this wrong? You gotta be kidding me. How can this be wrong? Come on, man. Oh, no. Ha. It does climb back up. Then we don't need to sort, right? Yeah, I sort because... No, you have to sort. You have to sort. Yeah, this shall be right. I mean, it's fine. It's still, I was thinking you might be able to save some time, but yeah, you just cannot break here. Oh, then why do you do this? We can just say rest equals to the minimum, rest, and this. All right, let's save a line. Okay. Try this now. Oh, terrible time, but yeah, we got it. Yeah, this the solution feels a bit overkill. A bit overkill. We first use union find to locate which elements in an array must be equal. Then we find the optimal, right? Find the optimal value that these elements must be equate to, such that the total operations are minimal. It's ON. ON times whatever O union find. It's just this. Everything else is ON, but like 3 rounds of ON. Plus, yeah, this is all ON. Not the best runtime. So I'm pretty sure there's a better solution. K-cycle. Find median of each GCD defined subarray. Explaining like you're a 5-year-old. The sum of all subarray of size K is equal if AI equal to this and AI equal to this. Yeah, that's true. As you roll a window of size K, remove element and add element. The sum to stay the same, the removed and the added must be the same. This can be also proven by contradiction. So for each position I, we collect all elements in the K cycle. Then we determine the median and perform. It is median. It is median, and we don't use union find. Yeah, I collect K cycle, 2K, until it, what if it rolls back? What if it keep rolling back? We use GCD to get all the elements in the cycle. Huh. So what you're saying is we can make this better by we're still doing the union find for this, but this we're gonna just do the medium. Well, if it's odd, that's the median. If it's even, what if it's even? It didn't say what happens if it's even. I guess it doesn't mind. Doesn't matter if it's even. Oh yeah, it doesn't really matter. You pick either one. You have to do the same change. I don't think it matters. Okay, so we'll return sum for n in array, for a in array. ABS a minus median. So solution 2, all right, still union find, but use median to quickly find the minimum operations to turn an array of values into the same value. Okay, let's see. How much faster can we get? We shaved off a few. But of course, the ultimate faster is going to be not using union find. So not using union find. Just find all the elements. All right, just finding all the elements. Just find all the elements with separated by k. Separated by k. I plus k, I plus 2k. How do we do this if we don't know the trick? So we loop. Yeah, but we loop. We do this, and then we loop back. So whenever we hit something that we have hit before, that's the end. And then you keep moving forward. Yeah, you can do that. So we can, let's try this. It's okay. Yeah, it's okay. So we can say rest equal to 0. Okay. And we say for okay. While array I is larger than 0. Larger equal to 0, larger than 0. Larger than 0. I can set it to 0. Okay, well, this is larger than 0. The equals. Okay, equal to this. Equals dot append array I, and then j equal to I. J array j equal to 0 and j equal to j plus k mod n rest plus equal to self dot find minimum equals and we say if equals. Okay, if equals, then we return rest. Let's see if this one's right. This one's right. So what is this GCD stuff? Oh my goodness. every GCD elements. Because I here and I go K, and I go K div mod. Why GCD? Because you're gonna start from something, and then with plus K, plus 2K, plus 3K mod, right? And if you mod, I don't know. What is this GCD stuff? N equal to 6 and K is 4, so every 4 element. Linear congruence. Sum of elements within, it means that whatever values. I know this part. AX mod n has solution if and only if GCD AN divides B. AX and B need to have the same remainder. AX and B. Okay, B is the index because I want I, right? I plus K, I plus 2K. So I need to get all of these. Well, honestly, it's I. It really has to be this mod n, right? And this mod n. So mod n. So it's I mod n and AX, A times K mod n. These two need to have root so it's just this is the x, right? This is the x. So for each x, if we need to have a root, only and if only if GCD AN What's A? A is K. Kn divides B. What? I gotta figure this out.